What if your Postgres database was the API and you didn't have to write any backend code at all? Every time you build an API, you write the same backend code over and over. Routes, controllers, validation, auth, all this just to talk to your database. Then you change one column and everything breaks. No custom backend code, no controllers, no ORM layer. That's what PostgREST does. It's the engine behind Supabase. It handles serious production traffic, and in just a few minutes, I'm going to show you how. Now, if you build APIs, this one hits the most annoying pain points in the whole stack: duplicated logic. You define the data in the database. Then you define access rules in backend code and validation somewhere else. Then we do the same for response handling somewhere else. Same system, multiple layers, multiple chances for things to break. PostgREST cuts through all this. It has over 26,000 stars on GitHub, and it's used by Supabase at production scale. It turns your schema into a production-ready REST API in just minutes. There's no ORM, no controllers. Security lives in the database, which means less duplication, less maintenance, and way more less time spent wiring all that boring stuff together. Let me show you. If you enjoy coding tools that speed up your workflow, be sure to subscribe. We have videos coming out all the time. All right, now let's actually build this thing, okay? Here is the setup. 3 containers, that's it. Postgres, PostgREST, and Swagger UI for some docs. Here's the Docker Compose file. There's nothing much going on here, just 3 services that I've wired together. I spin it up with our surefire command, Docker Compose. It's gonna get running, and I'm done. There's no installing dependencies, no setting up a server. Now let's look at the database. I'm going to run this Docker command here, and that's it. A super simple to-dos table, ID, title, completed, created, at all the basic stuff. That's all that's going on here. But this is the part where it becomes useful: row-level security. We define who can access what directly in SQL inside the database. No backend auth logic sitting somewhere else in our system. Here's the policy. I have anon full access using true with check true, so for now, everything is allowed. Now watch this. I'm going to hit get to dos with this curl command, and that's it. Full JSON straight from Postgres. No API code. Now building on that, let me filter it out now. It works immediately. If I sort it, boom, there we go. Now let's create another row, send a post request with a JSON body, and we're done. And it's already in the database. There's no ORM layer trying to catch up here. And here's the part that really gets people with this. Open API docs, auto-generated Swagger UI, it's just here. I open it and we get a full interactive API. You can explore everything, test endpoints, see schemas. So from 0, you now have full CRUD, filtering, sorting, pagination. You have basic auth via RLS and docs in just under a minute. So why do people even use this? Well, if that wasn't enough, because traditional backend work has a tax, and most of that tax is not product work. Really what we're doing is all this maintenance work. Right? If you think about the normal stack, maybe it's Express, Prisma, controllers, services, validation in one place. Then we have auth in another place. Your database logic is somewhere else entirely. Now compare that to PostgREST. Your schema defines the API. Your security is RLS. Your relationships already exist in the database. So instead of building a translation layer around your data, we just expose the data correctly. That's very different. Now compare that to a custom backend. You have to write everything yourself. That gives you flexibility, yeah, sure, but it also gives you a lot more code to maintain. PostgREST stays simpler. REST plus Postgres. Security is in the database. It's not scattered across middleware or root handlers. Your maintenance stays low because your API tracks your schema. That's why people like it. Now, to be fair, this is where people get in trouble, because once something starts to feel clean like this, people start acting like it solves everything. This doesn't solve everything, right? There's still things we have to look out for. There's going to be trade-offs, and you should know what to watch out for before you even touch this. What people love here is, well, kind of obvious. It's fast to build with, you can go from idea to working API really fast, and it does scale really well too. On top of that, right, Supabase kind of proves it. They're using this. But the downsides here are things like heavy row-level security usage is going to increase the database load, so you need to think carefully about how you design this. Complex logic can push you towards lots of SQL functions or views, and some people love that, and some people are going to hate that. So should you use this or even try it? Yeah, for the right projects. If you're building prototypes, MVPs, or anything centered around Postgres, then sure, why not? Give it a try. Right? You're going to move faster, you're going to write less code, and you get stronger security defaults by pushing the rules down into the database. Now, if your app has really complex logic, you may still want a thin backend layer on top, something small, a BFF layer for edge cases, but even then, PostgREST can do most of the heavy lifting underneath. So the big takeaway is this: PostgREST lets you ship faster, secure better, and maintain less. Your database becomes the source of actual data, and your API falls out of that instead of becoming its own separate system. If you enjoy coding tools and tips like this, be sure to subscribe to the Better Stack channel. We'll see you in another video.